Okay, so what are we looking at today? More blue LEDs, more sticky strip. No, actually we're looking at this, which is the little 12-volt lighting dimmer that's making it possible to change the brightness here. If I turn the lights up, you can see it a bit better. And this little black box, rather like some of the other things we talked about, is something that was built for a specific job and then became actually part of the sort of standard equipment because they're quite helpful, they're quite useful. It does more than one thing. Of course, it gives you the intensity control, as we see here. And if I turn the lights down again, you can actually see that it gives us really rather good intensity control. I mean, I can control that all the way from complete darkness, all the way up, and it's dark in person as well. It's not just dark on camera. All the way up completely smoothly with very fine control all the way up to full power there. So that's nice to have. The other thing it gives you is regulation. I've set things up here so that I'm actually running this from a lab power supply. And if we look at this meter here, it says 11.98 volts. That shows the power that's going into this thing. And if I set it to, I don't know, let's set it to 10 volts here. If I vary the power input, power output stays the same. And I can go down, it's hitting the low battery voltage cutout there, which we'll talk about in a minute. But if I go all the way up to, where a lithium ion battery would be, all the way up at 16, 17 volts, which is where they'd be fully charged, then the output remains the same. And we can do this all the way up to 24 volts. So we can use these on 24 volt batteries as well, should we feel the need. That's quite handy. I think the maximum these will handle is 30 volts, so it won't go too much higher. But it will certainly handle a 24 volt battery. Perhaps if you had a 24 volt lithium ion battery, they might go rather too high for this. But generally speaking, they'll handle most usual things. They will handle low voltage batteries as well, so you could run them from a camcorder battery like this if you felt the need to do that, as well as from a big chunky battery like this one. All things are possible. At the moment, it's set for 10 volts output, and regardless of what we do with the input, it stays the same, which is nice because now your lights don't get dimmer or brighter as you change and discharge batteries. The other thing it has is a low battery cutout. So as the power goes down, as we saw earlier on, if this was a 12 volt battery, you might agree that it was flat when it hit 10.5. So as we go down through 10.5, it cuts out, which is nice because now you don't over discharge and thereby ruin your expensive batteries. You can set this to various points. 10.5 would be too low for a lithium ion battery, but you can set it to various points, which we'll talk about in a moment. Inside is reasonably straightforward. Just to make things a little simpler, most of what's going on in there Most of what's going on in there is just this board, which is something you can buy for they're $10 or so on eBay, which you can see in the middle there. The rest of this is just wiring and connectors and things. The little meter which shows you the voltage and current is not essential. I mean, most people would just adjust it by eye. So you could leave that out. Again, it's just something that you would buy straightforwardly from eBay. Likewise, the breaker, this is rather like having a fuse, and it just goes in line from the input connector here to between the input connector and the board. But I've never once had one of these pop out. I've had 5 of these and we've used them all quite a bit, and I've never once had one of these pop out. It's just a case of having a disaster recovery, and just in case a bit of wiring comes loose, because these will protect themselves from overcurrent. If you put a big load on the output, these will just cut out, so that's helpful. So that's good. There's all kinds of other things that they will do, but mainly we're interested in the dimming, and the perhaps the low voltage cutout is useful. In order to turn it from being, I mean, these boards will do all kinds of things. These are just generic electronics. These will do reduction of voltage, boost of voltage. They will do all kinds of things. The input is limited. I think it's 5 to 32. Actually says on there. If you read it, it says on there below the input terminals there, 5 to 32 in, or 0 to 30 out, which you can adjust using one of these pots. This is the one that adjusts the output voltage. This one adjusts output current. We're not really that interested in limiting output currents. We'll leave that at the maximum. And this is the one that sets where the low voltage cutout sets in. So we can, for a start, we can adjust the output voltage so that it says 11.6, and we like the output voltage at maximum to be 12. So what we can do, if I can get in here without obstructing your view, we can quite easily just increase that to the point where it says a little bit too much. The point where it says 12, like that. No, 12, a little bit less than that. It's not a precision device for $10, but it does the job quite well. So there's your output set. Now, if we wanted to adjust the way that the low battery cutout works, let's say we wanted to reduce the low battery cutout to the point where it would, or let's say increase it. So if we're making it up for a lithium-ion battery that was nominally 14.4 volts, we might agree that that would be flat at, say, 12 volts. So to do this, you really do need a lab power supply, although that might just be another one of these boards, given that they have adjustable output. Set it to 12 volts, and then we take the leftmost of these controllers here, these pots, and wind it down up until the point where it just cuts out at the point where we want it to. And now we have something that's perfectly happy in the normal lithium-ion voltage range, but will then cut out when it goes down below, let's say 12, 13 volts. You can, of course, mess around with that until it works as you want it to. You could also reduce that to the point where you could run this from a 7.2 volt battery, and then yes, you could run 12 volt loads from your 7.2 volt battery within reason. I mean, of course, it won't allow you to run enormous loads from tiny batteries, but it'll boost the voltage if you need that done. The trick really is how you turn this, which is just a sort of generic piece of electronics, into something that's actually a usable dimmer. And of course, you want an external controller like this. And the way that's done is really pretty straightforward. This here is a 500k potentiometer, which you can buy very straightforwardly. Why 500k? Well, that just interacts with the electronics on this board in the right sort of way. I did it essentially by random substitution and figured out what worked. What that'll give you is a control setup whereby you can set the maximum here, as we did just a moment ago, and adjust it up to that point here. And to achieve that, you're going to solder these two green wires from the back of the potentiometer, which you can see in there, to the back of this board, which you can see here. You're going for the center and the left hand of this set of three. So the center one here connects to the center of that pot, and this other one here connects to the outside here. And that will then put you in a situation whereby you can adjust up to a maximum using this potentiometer here, but then control it up to that point using this external pot. So that's all quite convenient and easy. In terms of casing it, the most expensive part of this, believe it or not, is actually this metal box. I think a metal box is probably a good idea. Put it the wrong way around. I think a metal box is probably a good idea. These things operate at quite high frequency and they can cause radio interference if you're not careful, so probably a good idea to put it in a metal box. Other than that, it's really just a case of choosing what connectors you want. I used 4-pin XLRs here because that's fairly standard for 12 volt or thereabouts power. Other people might want D-taps. Of course, if you're doing 24 volts in or something else, then you might want a different power input connector. I don't want to do a sort of blow-by-blow how-to on this. I can do that. Let me know if that's of any interest. I've already got 5 of these. I don't really want to build another one just for the sake of demonstrating it. But it's drilling some holes and doing a bit of soldering. If you've not done any soldering before, I did something previously on soldering, basic soldering technique, which is something I think is quite useful to film and TV people of every stripe. But there we go, little lighting dimmer, which honestly there's not $25 worth of stuff in this thing. So there you go, dim your 12 volt lights, and that'll work not only for this but also for it's tripping out the low power limits there because we set it up for 12 volts. But there we go. Yeah, it'll work on incandescent lights, all kinds of things, and I hope that's useful. Bye.